Number 51. Lifetime of electronics. In a simple random sample of 100 electronic components produced by a certain method, the mean lifetime was 125 hours. Assume that the component lifetimes are normally distributed with population standard deviation sigma 20 hours. A. Construct a 98% confidence interval for the mean battery time. So let's write down the information from the problem. They say the sample size is 100, the mean is 125, and the population is 20. The sample size is 100. The mean, this is the mean for the 100 sample size electronic component. So the notation is X bar is 125 and the sigma is 20 hours. The confidence level they are given is 98%. We want to construct the 98% confidence interval. So we know the formula is the point of estimate plus minus the margin of error. So point of estimate is X bar plus minus margin of error is Z times sigma over square root of n. So we have 125 plus minus sigma is 20 and n is 100. We need to find Z and we use the confidence level 98%. So again, we cannot use the one in the middle, so we should use 1% either on the left side or right side. And 1% is 0.01. So I go to the GeoGebra, I enter right here, I use the left side 0.01 and I got negative 2.3263. Now copy the other side, we got positive number, so 2.3263, and you put the whole thing in the GeoGebra calculator. So we have 125. Now I do the minus first. Minus 2.3263 multiply 125 divided by square root of 100. I got 95.92. Sorry, I have its opposite. So 125 is X bar. 125 is X bar, and the sigma is only 20. It's not 125. So I got the answer is 120. One 20.3.34. And with the plus, we are copy out the same 125. Or what we can do is we just go here. Everything is the same, right? And then you change this minus to the plus side. So we got 129.65. For the GeoGebra that you want to calculate the whole part, so we want to enter like this. The confidence interval that we have is confidence level that we have is 0.98. The mean is 125. And sigma is 20. So you can see that we got the lower limit is 120 and the upper limit is 129. If you want detail, then you look at the last line, 125 plus minus 4.6527. So after the plus or minus 4.6527 is the margin of error. So we write down the conclusion is there is 98% confidence that the mean, so look at the question, so we copy the question. The mean battery life is between 120.34 and 129.65. Part B, we need to find the sample size. The formula in the book is n equals z times sigma divided by the margin of error square. So z is 2.3263. You can enter the z plus or the z minus. However, we will square, so that's why it will become positive. So in this case, I just use z positive to be easy. Sigma is 20, so multiply 20 divided by the margin of error. So I did not calculate the margin of error, but margin of error is this part. So I copy from the GeoGebra, so we got 4.6527. Now we enter this whole thing in the calculator. Okay, I open the parentheses first. So 2.3263. I need to have the fraction first, right? So 2.3263 multiplies sigma is 20 and divided by m. Margin of error is 4 point, and I forgot the m, so 4.6527. And then you exponent 2. So we got 99.99. And so on. And we have to round it up because we are calculating sample size, and the sample size we don't have the GeoGebra work. First of all, it's a manually work only, and for the sample size we have to round up, so it's go to 100. Sample size have to be the whole number because it's a counting number, so we make 100. So right here in the book we are using this formula. And it said that we need to have the whole number for the sample size. This formula given is not the whole number. So we calculate is not the whole number. And then after that, we have to round it up to the nearest whole number. Because by rounding up, we can be sure that the margin of error is no longer than the desired value m. It's no greater than the desired value m.